In healthcare facilities equipped with life safety branch emergency power and standby generators for exit and egress lighting, specific locations still necessitate battery-powered emergency lighting. These requirements are outlined in National Fire Protection Association 101 Life Safety Code, specifically Section 17.7.1.2, which details the placement of emergency lighting when using a standby generator. Emergency lighting from a standby generator must be installed in several key areas. Firstly, exit pathways. Secondly, discharge areas of exit stairs and ramps. Thirdly, lobbies and corridors. Fourthly, critical life safety system areas. Fifthly, fire command centers. And sixthly, any other areas deemed necessary for safety. Furthermore, Section 17.7.1.2 stipulates where battery-powered emergency lighting is specifically required, even when a life safety branch is available. These locations include, firstly, rooms containing major electrical distribution equipment, for example, generator rooms, and secondly, critical life support areas, such as operating rooms and intensive care units. It's important to note the distinction between using battery-powered lighting as an alternative to generators versus using them in conjunction with generators. National Electrical Code 700.12c states that battery-powered emergency lighting is permitted to be used in lieu of a standby generator, but it is not required when a standby generator is already provided for emergency lighting. However, the Life Safety Code identifies specific areas where battery-powered lighting is mandatory regardless of generator presence. The conclusion is that within a healthcare setting that has a life safety branch and standby generators for exit and egress lighting, battery-powered lights are still a must in generator rooms and critical life support areas. This stems from the need for immediate backup lighting for critical electrical and life support equipment during power failures, ensuring safety and functionality irrespective of standby generators. These requirements are not just about redundancy, but also about ensuring immediate illumination in the event of a power disruption. Generators, while reliable, have a startup time, even if it is short. Battery-powered lights offer instantaneous illumination, which can be crucial in areas like operating rooms where a sudden loss of light could have dire consequences. The placement of these battery-powered lights needs careful consideration. They should be positioned to provide sufficient illumination to allow staff to safely operate equipment and attend to patients. Regular maintenance of these battery-powered systems is crucial. Batteries need to be tested and replaced as necessary to ensure they function correctly when needed. The type of battery used in these systems is also important. They should be designed for emergency lighting applications and have a long lifespan. Furthermore, the Life Safety Code and the National Electrical Code undergo revisions periodically. It is imperative that healthcare facilities stay updated with the latest versions of these codes to ensure compliance. Failure to comply with these codes can result in penalties and, more importantly, compromise the safety of patients and staff. Regular inspections and audits of emergency lighting systems are recommended to identify any potential issues and ensure compliance. The design of the emergency lighting system should also consider the specific needs of the healthcare facility. For example, a hospital with a large number of critical care patients may require more extensive emergency lighting than a smaller clinic. The emergency lighting system should be integrated with the facility's overall emergency plan. This plan should outline procedures for responding to power outages and other emergencies. Staff should be trained on these procedures and know how to operate the emergency lighting system. In addition to the Life Safety Code and the National Electrical Code, healthcare facilities may also be subject to other regulations related to emergency lighting. For example, the Joint Commission, an accreditation organization for healthcare facilities, has specific requirements for emergency lighting. It is important for healthcare facilities to be aware of all applicable regulations and to ensure compliance. The cost of installing and maintaining emergency lighting systems can be significant. However, it is important to view these costs as an investment in the safety of patients and staff. The benefits of having a reliable emergency lighting system far outweigh the costs. In conclusion, battery-powered emergency lighting plays a crucial role in healthcare facilities, even when standby generators are present. By adhering to the requirements of the Life Safety Code and the National Electrical Code, healthcare facilities can ensure the safety of patients and staff during power outages and other emergencies. Regular maintenance, proper placement, and integration with the facility's emergency plan are essential for ensuring the effectiveness of the emergency lighting system. Staying updated with the latest codes and regulations is also crucial for compliance and safety. By taking these steps, healthcare facilities can create a safe and secure environment for everyone. Therefore, the dual requirement of standby generators and battery-powered lighting ensures a layered approach to safety. The generator provides a reliable source of power for extended outages, while battery-powered lights offer an immediate illumination during the brief period before the generator kicks in or in specific critical areas as mandated by code. This combination minimizes risk and maximizes the safety of patients and staff. Remember to always consult with qualified electrical engineers and code officials to ensure your facility meets all applicable requirements. The information provided here is for general guidance only and should not be considered a substitute for professional advice. The NEC, or National Electrical Code, Article 700 provides further information. Emergency systems are legally required and intended to automatically supply illumination, power, or both to designated areas and equipment in the event of failure of the normal supply or in the event of accident to elements of a system intended to supply, distribute, and control power and illumination essential for safety to human life. Article 700.1 discusses the scope and emphasizes that the provisions apply to the electrical safety requirements of emergency systems providing power for illumination and equipment essential for safety to human life. These systems are intended to supply power automatically to the areas specified in the event of failure of the normal supply or in the event of accident to elements of the system intended to supply, distribute, and control power and illumination essential for safety to human life. Emergency systems are designed to provide power for specific applications such as illumination, electrically operated equipment, or signaling systems. Legally required standby systems are those systems required by law or by a governmental agency to supply power to specific loads or equipment. These systems are intended to supply power automatically to selected loads other than those classed as emergency systems when the normal source of power fails. Optional standby systems are those systems intended to supply power to public or private facilities or property where life safety does not depend on the performance of the system. Optional standby systems are intended to supply on-site generated power to selected loads, either automatically or manually. These systems are often used to provide power for critical business operations or to maintain comfort levels during power outages. The coordination between these different systems is crucial to ensure a comprehensive and reliable backup power solution. Emergency systems must take priority, followed by legally required standby systems, and finally optional standby systems. This ensures that life safety systems receive power first, followed by other critical loads, and finally optional loads. Regular testing and maintenance of all backup power systems is essential to ensure their reliability. Testing should be performed in accordance with manufacturers' recommendations and applicable codes and standards. Maintenance should include regular inspections, battery testing, and generator servicing. Proper documentation of testing and maintenance activities is also important. This documentation can be used to track the performance of the systems and identify any potential problems. In addition to the technical aspects of emergency lighting, it is also important to consider the human factors. Emergency lighting should be designed to provide adequate illumination for people to safely evacuate a building or perform critical tasks. The color and distribution of the light should be carefully considered to minimize glare and maximize visibility. Signage should be clear and easy to read, even in low light conditions. Staff should be trained on how to use the emergency lighting system and how to evacuate the building in the event of a power outage. Regular drills should be conducted to ensure that staff are familiar with the procedures. The emergency lighting system should be designed to be user-friendly and easy to operate. Switches and controls should be clearly labeled and accessible. The system should be designed to minimize the risk of accidental activation or deactivation. The emergency lighting system should be designed to be energy efficient. LED lighting is a good option because it consumes less energy than traditional lighting. The system should be designed to minimize light pollution. Light pollution can be a nuisance to neighbors and can also disrupt wildlife. The emergency lighting system should be designed to be environmentally friendly. The system should use materials that are sustainable and recyclable. The system should be designed to minimize the environmental impact of its operation. The emergency lighting system should be designed to be secure. The system should be protected from unauthorized access and tampering. The system should be designed to prevent cyber attacks. The emergency lighting system should be designed to be resilient. The system should be able to withstand natural disasters and other emergencies. The system should be designed to recover quickly from failures. The emergency lighting system should be designed to be adaptable. The system should be able to adapt to changing needs and requirements. The system should be designed to be scalable. The emergency lighting system should be designed to be sustainable. The system should be designed to be economically viable over its entire life cycle. The system should be designed to be socially responsible. The system should be designed to promote safety and well-being. The emergency lighting system should be designed to be innovative. The system should be designed to incorporate the latest technologies and best practices. The emergency lighting system should be designed to be a valuable asset to the healthcare facility. It should provide a safe and reliable source of illumination in the event of a power outage, and it should contribute to the overall safety and security of the facility. The installation of battery-powered emergency lights, alongside generator-supplied emergency lighting, can be strategically considered for areas such as nurses' stations, medication rooms, and other critical areas where immediate access to resources is vital. By integrating both systems, healthcare facilities ensure a robust and comprehensive emergency lighting solution that addresses various scenarios and critical needs. This combination contributes to a safer and more secure environment for patients, staff, and visitors.